So ideally, our aim or our area of focus is in building these smart factories or smart cities or something like that, in which everything is connected to internet. And so I thought maybe I'll just give you an introduction of the industrial revolution that has happened so far. So right now we are in the industrial revolution 4.0. I think you might have known industry 4.0. This is where we are working right now. And before that, in the overall industrial revolutions, we had at least three revolutions, which helped us to streamline the processes and add more uh, add more flexibility in the mass manufacturing firm, which changed the overall thinking on how change the overall idea of how the goods are being made. So I'll just give you introduction of each what each industrial revolution is to get into industry 4.0, where I'm working on right now. So industry 1.0. So this is the first revolution which the industry has seen so far. So it has started in about 1700s to 1800s. So this is where the steam powered engines and the water steam engines were invented. So before that, all you had was only the manual labors. The manual labors used to do manufacturing one by one, and it will take a lot of man force, but the efficiency or the output that is expected is not as expected. So this is something we call it as mechanical era, where you have the machineries, the levers, the pulleys, and everything to do the work. And this is one industrial revolution which had happened at least 300 to 400 years, 300 years before the existing timeline. And after this, we had jumped into Industry 2.0. So this is what we call it as electrical era, where we invented some electrical machineries. So here the mechanical levers and pulleys were replaced with some motors and some electrical sensors. So this is where we had a era where we cooperate with the electrical system. So ideally, you'll have a person who will coexist with an electrical machine. They'll work together to get a job done. So maybe you can take an example of an industry where you have the machineries and the person working together. I'm just finding an example to just elaborate to you guys.
Nikhil, whether your network is okay,
Uh,
somewhat intermittently voice breaking, I guess. Whether my voice is clear, is it okay, Nikhil?
came into existence only after this, and then we stepped into industry 3.0. So it is called as electronic era. So here the electronic machineries were actually invented now. So just to give you an overall idea, the next machine can take over. In to put in layman terms, the machines should learn to communicate with each other. So that was a big problem that was faced in Industry 3.0, but it is being overcome now, and the machines can talk to each other in a way where it will say, "Hey, my process is completed. You can take over to the next process." So that is one big advantage here, and all these machines are powered by artificial intelligence. That is one biggest advantage that I see in Industry 4.0. So rather than you giving the task to the machine can adapt to itself uh, in the events of catastrophe or any other want the machine to adjust. So in the past, you need humans to just adjust the systems or adjust the valves or some kind of thing in case if there is some change in the product. But now, since we have artificial intelligence and you have some uh, main technologies to make the machines figure out things by itself, this is one of the huge leap in the industrial era. So these are some main evolutions of Industry 4.0 technologies. As you can see here, the autonomous machines is one of the key items that I've been working on, and the industrial IoT. The IoT is also one of the items that I've been working on. And the third item that I have here, the big data analytics, is now you have chunks of data, chunks and chunks of data to process. So that is where the big data analytics came in, where you can have a lot of data that is being collected by the physical system and which can be dumped into the digital world. You can process them and you can do some predictive maintenance kind of thing. And then you have cloud computing. So now you have all the machineries in the industry floor, but the actual you would need some heavy processing to process all those data, right? So that is where the cloud computing comes in. So uh, cloud computing is where you will have a large server or computing system which is capable of processing at least large chunks of data, maybe in a flash. It is highly enabled. So data in the factory floor, and then pass it to the cloud computing system, which will collect all this data, and it will be able to predict how the overall machinery process is going on, and it can give you some hints like, hey, this bottle uh, this bottle plastic that is required is going to get over. You need to change the, or you need to refill the plastic molding machine, that is plastics in the molding machine. Or it can also say you that, hey, this lever that you are using has some friction that is being collected from our sensor. So you need to re-oil the machine. So those kind of items also can be done through cloud computing. And in the 2020 report of the Industry 4.0 adoption, you have 17 technology that has been listed as that is being explored by the Industry 4.0 technology. I've just put it to in the screen so that you can have a look into these things. So I can proudly say that I've been at least worked in at least 8 to 9 technologies here. I hope you would have been aware of these technologies. If you would like me to elaborate All right. Uh, this is some report that was generated, which is showing the adoption rate at each technology, at each firm. So as you can see, in the automotive firm, the digital adoption has been in the rate of 36 percentage now. The computer and electronics manufacturing and fabricating industry has adopted it at least at most 29 percentage. And you have various diverse industries at which the adoption rate is there. So this is just to give you an overall idea of how the industry has been adopting to the digital technology so far. And how Industry 4.0 impacts our life. So this is one thing. Maybe I'll put forth. This is consumer technology. Rather than using it in industry firms, you can use it within the consumer itself, like our normal consumers. So wearable devices, smart kitchen, smart factory, and these things are something that the consumers get to use first. So as you can maybe imagine, like now you have everyone has phone. So phone has become a physical extension of a person. So you have internet connected to you. So in a way, you are a cyborg who's connected to the internet. So this is where the wearable devices comes in, and smart kitchen. So smart kitchen is where everything is connected to internet, and you can even you can just give voice commands to automate the kitchen and do the work for you. So this is something that is being working on right now. But I'll say that maybe in 10 to 20 years from now, you wouldn't feel the need to have kitchen inside your home, because everything you need will be mass produced and it will be delivered to you as you would want. Like in Industry 3.0, the one thing that was missing was customization as per your needs. So Industry 4.0 is addressing that. Imagine you ordering something in Swiggy. Let's say you order a burger. Right now, what you can do is you can order it in the basic specification that has been given there in the app itself. But what you will be missing is that you would need some customization in the product itself, so that you would like that. That is something we can make that happen with the Industry 4.0, because you will have everything automated, and the machines will take over, and the machines will make sure that the specification that is being given as input is met before it is being delivered to the customer. So that is some details of the smart kitchen and the smart factory. And coming about autonomous driving, so this has been already started in countries like China and US. You have Google cars, and Uber is also doing some research, and it is deployed some autonomous cars where everything is controlled by the machine itself, where you have cameras uh, that is doing the job of sensor vision, and it will automatically go to the navigated place through the GPS, and everything is done there. So now you have extra seat of the driver where which you can use to go to other places, and eventually maybe in the upcoming years you would not even need a driver to drive you to your preferred location. So that is some extent at which we are working on. That is where the security comes as a big challenge, and there have been some technology that we've been working on which enables security and enhances in a way where we have secured control of our desired data. And IT and OT integration is where you have the software part that is sitting in a block of PC, but you need that to communicate with the operational technologies. That is, you give a command motor, it has to start in the physical device. Right? As a matter of fact of speaking, it might sound easy, but actually, a couple of blocks involved in order to make the motor functional itself. So that is one of the major area of challenge that is being faced by industry. And the other thing is cost. So the physical technologies that is there, in order for you to automate that, to change the entire working setup itself in order to make it completely digital. And so, as I've said, you have a couple of machines, right? So uh, you need them to talk to each other. That is one of the huge challenge. So interoperate, as the word says, you need the machines to interoperate with each other. Dairy Milk chocolate company. So the chocolate manufacturer actually putting in the chocolates that is required to manufacture the chocolate. Then you will have the slicers, the next machine, which will slice these things up. Once the chocolate is maybe it is baked in the oven for some degree of centigrade, and then you will pack them once it is sliced. Like you will have the separator to separate the sliced packs, will package them into the required quantities. So you will have at least 20 to 30 machines that is being used in this process. So the problem is that the machines have to communicate with each other in order to do this efficiently. So that is where the interoperability comes in. So just to give an idea of the pre-adopters of Industry 4.0, these are the three areas where we see the Industry 4.0 is adopted: the North America, Europe, and China. So I would say we have our customers in North America and Europe, and they have been our major customers in. Uh, we help them integrate or digitalize their industries to make it completely digital, and we do some technological integration in order to Industry 4.0 era. And when it comes to Industry 4.0 in India, I think still there are some proactive measures that needs to be taken to just face up with other countries. And I would say there needs to be a shift in the mindset before there is a shift in the capacity. So people have to accept the fact that machines are going to replace us. So in order for us to coexist with the machines, we have to be acquiring some new skill sets, and we have to be in phase with the technology. So that is one thing that I would like to put forth here. So I will just elaborate on the interoperability. So protocols ideally, typically, right? So as you can see in this photo, you have at least 6 to 7 machines, right? So once the one of the machines is connected to the company B will have another protocol. So it is hard for them to talk to each other. Let's say I speak in English and the other one speak in German, right? So this is where the interoperability standard comes in, and I would say there is a technology that is being developed throughout the world. The major leading industries came to an agreement that we needed an interoperability standard in order to make the machines to talk to each other. So that is where the interoperability standard comes in. I would say there is an one language for industrial communication that is called OPCUA. This is an open process communication unified architecture. This is where people develop an application and they will have an OPCUA developed for it in order to make it interoperate with the other machines. So this is a purely application layer protocol where we can use this to make the machines to interoperate with each other, and this actually makes things simplified. And Microsoft is one of the uh, pre inventors of this technology. Like they had OPC technology, which is a classic example for the OPC UA. And UA, the unified architecture, is where this adds one more layer to the technology, where you can use this technology uh, to get it deployed in systems where the size doesn't matter. Like you can get it deployed in an enterprise layer cloud platform. You can get it deployed in small edge devices or some sensory devices to the factory devices. So this is then you can deploy it in any architecture that you want. Since it doesn't have a footprint specification, you can deploy it in a small uh, memory devices kind of thing. So the other item that we've been working on is time sensitive networking. Imagine you've been doing some operations at a set of time, right? So let's take an example of a egg grading machine. So you have eggs coming from the industry. The egg grading machine will grade all these eggs and find out which one is good egg or bad egg, and finally they will pack them. Okay. So before the industry 4.0, some manual intervention is required, and they will finally grade and assemble the eggs in maybe 2000 x per second. But now we have synchronized motion with the devices, right? So what you can do is you can gradually assemble these things, and right now we've been operating in sub milliseconds. So uh, the synchronization is in the offset of nanoseconds. And right now what I can say is that we've been working in mass manufacturing and assembling the eggs in a rate of millisecond. And this is the rate at which the industry is progressing right now. And that is where the time sensitive networking comes in. It is an Ethernet protocol where we can do wonders with the existing data bandwidth available. So my work in OPC is in domain. So I, along with my company, is a member of the OPC Foundation. The OPC Foundation actually standardizes the OPC protocol for the interoperability. And my company is only service provider in the OPCUA FLC community, which is, to abbreviate, FLC. It is a field level communication committee which mandates how to follow the protocol and how to develop your machineries and the devices for the OPCUA technology. And I've been listed as an OPCUA expert among the overall 37 claimed experts worldwide. And Kalasalingam actually a quick uh, peek into the website itself. So this is the OPC Foundation website, and you can see my name here. So you can see it is a very short list, right? So it is very, I would say this is one of the proudest moments for me to getting me listed into this website. And maybe I'll just give you one example of how we do synchronization. So this is one of the video that have been taken in an international trade fair. Uh, this is called SPS, and this was taken way back in 2019. So the orange box that you see here, which I'm highlighting in the mouse, this is a PLC, industrial PLC, and the yellow circles that you see at the end, these are motors. Okay, so our for this trade fair was to do a synchronous motion with these motors and this with these sensors. So ideally, these are different PLCs. So they'll communicate with each other to do a synchronous motion. So just to put you in numbers, uh, these motors are synchronous of 2 ms. So 2 millisecond is where these at which these devices are synchronous. So we had to actually go into sub millisecond like slow mo capturing video in order to record the synchronicity at which it used to operate. To do some trade fairs where we represent these technologies and we attract customers and we get some orders for us to execute. And this is one of the white papers that we have created to showcase the technological extent at which we can push the time-sensitive networking and OPC. You can see there is a word here, PubSub. PubSub means publish and subscribe. So with PubSub, you can achieve wonders rather than going with the server client mechanism. Just to say, have actually will use the PubSub mechanism. Like you will have to be subscribed to a particular scheme. Let's say you will subscribe to a cricket score, and then you will the main publisher, which has all the data, will publish the cricket score to all your phones. So that's it. That is some simple layman terms example of PubSub, and we use OPC PubSub to make the devices interoperate and communicate with each other. So we I have co-authored in this to share and benchmark how far we can push with the existing missions that are available. So here we had used to industrial PCs to communicate with each other, and we've been using this to see how at what extent can they be synchronous. Okay, so this is something I would say we have the synchronization at a precision of microsecond here. So this is a 3D graph that we have exported. You can see that we have the jitter of the machinery itself recorded at the range of microsecond. So we are pushing further, but uh, I think it is achievable. It is safe to say that now we have the synchronous precision of the machine itself operating at the range of close to 100 to 200 microseconds. And we have a huge test infrastructure available. So we use uh, German German co-partners of us to do some testing and automation. So for this paper, we've been using the co-authors, the OCDL and Fraunhofer. Those are two big companies that is there in Germany. We work with them to bring some uh, technological hardware and uh, software support in order to do some testing and publish white papers like this. So that is all I had for the presentation. Any questions that you have? Feel free to ask any questions or any doubts that you had with respect to the presentation or the nature of the work that I have.
Dear students, you just kindly ask your doubts and clarifications. And now our next semester is completely for our project work only. So you can also clarify. He is ready to suggest and he is ready to guide us also. Okay, Nikhil, I am having one doubt, Nikhil.
Okay, sure.
And generally for like networking, we are having some certifications like CCNA. You already know about that.
Yes, yes.
Likewise, now for IoT also, any separate certifications is there? Like,
Okay, you mean you do we have any certified course that we can take up to make sure that we are a certified IoT
yes, yes,
expert,
yes,
something like
like
that?
that,
Yes.
like that. Any
Okay, so I would say it depends on the technology that you are interested on. Like in IoT, you have uh, multiple protocols which we can use to get the job done. So
okay,
let's say I'll take this video as a reference point. So here you have multiple PLCs and motors, right? So
okay,
if it is Siemens, they will demand some technology expertise for which you have to learn their software and do the uh, do their operations to get the job done. So
mm,
I would say now what I can tell you is that you can uh, get your basics right, and based on the job that you get, you can expertise on.
okay. Okay, thank you, Nikhil, for your wonderful lecture on industrial IoT. So we also clarified some new things with respect to our seminar. I hope it will be useful for our students also. And now those who are attending, nearly some 30 to 40 students are final year students. Okay.
Okay.
So